So what we're going to do is we're going to start AQA GCSE Maths Foundation 4360. That's the exams that you're taking, and this is going to be for Unit 2 today. Right, so Unit 2, we're going to cover numbers, basic algebra, sequences, fractions, decimals, coordinates and graphs, equations, inequalities, percentages, indices, formula and ratios and proportions, okay? Not particularly in that order. It's the most important of the three papers because it's the paper without the calculator. It's got the hardest pass mark, okay? People fail on this one, pass the other two, and if you fail badly on this one, you cannot make up the marks on the other two. So this is the most important paper. The other reason it's the most important paper is because it's the first time you see some of these subjects that you cover on the other two papers as well. So stuff like numbers, basic algebra, fractions, decimals, coordinates and graphs come up in all of the other papers, okay? So you have to have a real grip of these things from now because you're going to carry them forward into the other subject areas. So what we'll do is we'll start off as we did in week 1, and that's on numbers, okay? Numbers are generally called integers. The door is shut. What's an integer? Anybody remember what an integer is? Sam?
A number that can be positive or negative.
A whole number that can be positive or negative. So we're just going to concentrate on whole numbers for the next couple of minutes, okay? So with whole numbers, at GCSE level, you have to know the whole numbers up to billions, okay, which is 1,000 million. Then they might ask you to sort these big numbers. They might give you football crowds to put into order. They might give you playing cards to sort into a particular order to find the biggest number, the smallest number, and so on, okay? As part of numbers, you might get something to do with estimation. So you might get questions about families going on holiday and the holiday costing £199 for an adult and £99 for children. If you calculate it exactly and you come up with £498 for this holiday, you will lose marks. Estimation means round the number to a sensible number to make the calculation easy. So £199 becomes 200 and so on. In whole numbers, there's two main kinds of rounding that you need to be aware of. The first kind of rounding in whole numbers is to a significant figure. So if I said I had 23,512 and I say to two significant figures, what are the significant figures? The 2 and the 3 are the significant figures. And you base your answer on the next number along. And if the number is 5, what do? We round it up. So 5 is the key thing with rounding, whether it's significant figures, decimal places or whatever. It's the number 5, and 5s go up. So that becomes 24,000, okay? So you can round to significant figures. You can also round to place values. So you might end up with this number, 23,512, and it could say round it to the nearest 100, which is talking about the hundreds column. And the same rules apply. The 2, 3 and the 5 don't change, because the next number along is the number 1, and then you round it. Okay, so that's rounding to the nearest 100. The rules of number are addition, subtraction, multiplication and division, and you have to have a process for doing that in Unit 2. You've not got a calculator. You will get lots of addition, subtraction, multiplication and division. In Unit 2, the numbers are going to be nice and round. So when you do a division, it's not going to be 0.2345. It's going to be £6. It's not going to be £6.25 or something. So a lot of the rules of number at this level should give you nice round numbers. Okay? BODMAS or BIDMAS stands for brackets, indices or order, division and multiplication, addition and subtraction. And this is the rule that tells us the order to do things, okay, if there's no other guidance. So if you have a multiplication, 2 plus 3 times 4, addition and multiplication in a question, what do you do first? The multiplication, because that's what BODMAS says. Okay, so you do the 12 first, and then you add the 2 to get 14. So it tells us what order to do things. However, the A and the S and the D and the M are paired together. So if I had 6 minus 2 plus 5, what would I do first there? Amber?
What was the question?
You're doing 1,000 mark. You're not looking at what I'm doing here. You are staring down there, doing your own thing. You need to be on task. This is your last chance to do any revision before this paper you're going to do in an hour. Okay? 6 minus 2 plus 5, what would I do first?
6 minus 2.
Everyone agree?
Yeah.
Yeah? You work from left to right when you're left with addition and subtraction, the A and the S. So it's 4 plus 5 is the correct answer. Just for Anthony, if you do it the wrong way around, if you think addition comes before subtraction and you do the 7 first, 6 minus 7 is minus 1. So you can get the wrong answer on a very simple question like that if you're not aware of that rule. And the A and the S are together. Addition and subtraction are at the same level. You read them from left to right. Negative numbers, you have to be aware of negative numbers. You're going to be adding negative numbers, subtracting negative numbers and so on. So if you have minus 5 and you take away another 2, minus 5 minus 2 is minus 7, and you're going to get lots of questions like that on negative numbers. Okay. We then moved on to fractions. Fractions, correct word for the number at the top is the numerator, the number on the bottom is denominator. Again, you will need to order fractions. If it's just a simple comparison, if they say what's bigger, a third or a fifth, the bigger the denominator, the number on the bottom, the smaller the piece of pizza you're going to get. So the bigger number is a third, a fifth is smaller. However, if they say to you, compare 2/5 with 3/8, which is the bigger and which is the smaller, you've got a problem because you're comparing apples and oranges. And that's where this thing comes in, equivalent fractions. And that's really, really important in fractions for comparing them, for adding them, and for subtracting them. So if I've got 2/5 and 3/8, how do I compare them?
Multiply it till you find the same number on the bottom.
Excellent. So what's that in this case?
40.
40, good. So if we use 40, we're comparing apples with apples, okay? So 5 goes into 40 8 times, because that's what I've multiplied it by. 8 times 2 is 16. 8 goes into 40 5 times 3 is 15. Okay, so now I can compare apples and apples. 2/5 is 16/40, 3/8 is 15/40. I can compare them side by side. I can also put an addition sign in or a subtraction sign to actually carry out addition and subtraction, and that's why equivalent fractions are so important. It allows you to compare them, add them and subtract them. You will also need to multiply and divide them, and they have their own rules as well. So if I had 1/2 times 1/3, what's the rule for multiplying fractions?
What you do to the bottom, you do to the top.
Not quite, that's what we call equivalent fractions. To multiply a fraction,
The denominator is the same.
you multiply the top and you multiply the bottom. So 1 times 1 is 1, 2 times 3 is 6. So when you multiply fractions, you multiply the top by the top and the bottom by the bottom. If I was dividing fractions, 1/2 divided by 1/3.
You take 2 from 3. Would you take 2 from 3?
No. There's a rule for this.
Is it, I was just going to say.
You inverse and multiply. So the second fraction becomes 3/1. The first fraction stays the same. And instead of dividing, you turn it into a multiplication. We know how to do multiplications now. 1 times 3 is 3, and 2 times 1 is 2.
I've only done that to 1 though. Yeah.
Because that's the rule. You invert and multiply.
Can it be any? Can you choose it?
Whatever, no, you have to do it to the second one.
Oh, okay.
It has to be that one. Okay, lowest terms is the opposite of equivalent fractions. So if you get a question and the answer comes out like that, what are you going to do to it? Simplify it. And how do you simplify? What you said earlier.
What you do to the bottom, you do to the top.
Exactly. So if I divide the top by 3, because 3 goes into both of them, I get 3. If I divide the bottom by 3, I get 4. So 9/12 is equivalent to 3/4. It's the same fraction, we're just tidying it up. Okay? So this whole thing of equivalence is really important, going one way or the other, multiplying the top and the bottom by the same, dividing the top and bottom by the same. It keeps the fraction the same, just the numerator and the denominator changes. Improper fraction is what? Sam? The numerator's bigger, so 6/5 is an improper fraction, and they could ask you to turn it into a mixed number. A mixed number would give me what? A mixture of integers and fractions. So you're going to get 1 and 1/5, because 5 goes into 6 once, remainder 1, and the remainder goes over the denominator. Okay, so that was fractions really quickly. Decimals. You have to know how to add, subtract, multiply and divide decimals, and you have to have a process for doing that. Okay? A lot of people get multiplying decimals wrong because they're not taking the decimal point away and then putting it back. Okay? The other really important thing about decimals is the place value of the decimal. Okay? So 0.2 means what? What is 0.2 equivalent to? What does its place value tell you that it's worth? Yeah, it's the tenths column. So 0.2 is the same as 2/10. That's what the place value is. 0.25 here is what? A quarter is 25 over 100. And if you were simplifying it, you're quite right, Anthony, it would be a quarter. Okay? So decimal places have values as you go down them. Tenths, hundreds, thousands, just like units do when you go up. Okay? So you have to be able to add, subtract, multiply and divide decimals. The other thing we put with those are percentages. So fractions, decimals, percentages all go closely together because a percentage is something out of 100. You're forcing the denominator to be the number 100. Okay? So 1% is 1 over 100. 65%, 65 over 100. If you were comparing something, for example, we have 5 out of 8 students here today, you would be 5 out of 8 times 100 would give you the percentage. Okay? If we had, I don't know, make it easier for us, 5 out of 10 students were here, 5 over 10 is a half times 100 is 50%. You can also do that. You don't have to divide 5 by 10 first. You can divide the 100 by whatever the denominator is, and it makes it easy. Especially if you're doing something like, I don't know, 2/5 of 100. 5 goes into 100, 20 times the 2 gives you 40% straight away. You don't have to divide 5 by 2 first, okay? And that was a top tip when we did percentages. In Unit 2, this is a given, right? You will get a percentage question and it will involve the 10% rule, okay? So they will always give you something 10%, 20%, 15%. All you need to do there is work out what the 10% value is of something by dividing it by 10, and then either half it for 5%, double it for 20%, and so on. So 20% of 70, 10% is what? 7, so 20% must be 14. So it's a really quick way of doing percentages. Don't forget to show you working out. If you get something as straightforward as that, and it's 2 marks, say 20% of 70, don't be tempted to just write 14 in. Show you working out, okay, exam technique. This relationship between fractions, decimals and percentages you must know. Every single paper has a question that links a fraction to a decimal to a percentage. Whether you're comparing them side by side, whether you're given one value in a percentage and another value as a fraction, you have to be aware that they're all related. They're the same thing in a different format. If I said to you a half, what does a half mean mathematically? What is a half? It's 1 divided by 2. A half means 1 divided by 2. It's just written in a different way. That's what it means mathematically. So if I divide 1 by 2, so I've got 1 and I divide it by 2, 2 doesn't go into 1, remainder 1, 2 goes into 10 5 times. So the reason a half is 0.5 is because when I divide the 1 by 2, it gives me 0.5. We just talked about this. What does 0.5 mean as a decimal? 5 tenths. If I simplify 5 tenths, what does it give me? A half. Yeah? Percentage. Decimal multiplied by 100 gives me the percentage, so 0.5 is 50%. What does 50% mean? We just talked about it. 50 over 100. That's what percent means, something per 100. Okay? If I simplify 50 over 100, it gives me a half again. So all these things are related. Okay? It's not a coincidence that a half is 0.5 is 50%. It's because when you do the maths behind them, they're all the same no matter which way you do it. Okay? So if you get a question that compares them, put them into one of those 3 formats that you're most comfortable with. Then talked about ratios and proportions. Ratios is where you compare parts with parts. So for Pete's famous cake, and I was mixing flour with sugar, okay, we would say 3 parts of flour to 2 parts of sugar. A proportion is exactly the same information but given to you in a different way. But a proportion talks about one of the parts and the total. So Pete's cake is 3/5 made up of flour. So you're talking about one of the parts, which is 3, and fifths, 5 parts, that my cake is made out of, because the 3 parts and the 2 parts give me the 5. So if I was talking in a proportion way, generally proportion questions come across as fractions, because they're talking about 3/5 of Pete's cake being made up of flour. 2/5 of Pete's cake is made up of sugar. And that's how you would put the question across as a proportion. If you're putting the question across as a ratio, you would say 3 to 2 flour to sugar. And don't forget, when they write the question down, it's in the same order. So if it's written in words and it says the ratio of flour to sugar for Pete's cake is 3 to 2, the 3 is the flour, the 2 is the sugar. Okay. So what sort of ratios questions you can get? You can only get 3, 4 types of ratio questions. Okay, so that's ratios. One of the most important things we use ratios for is something called Unitary Method. Unitary Method converts one of the 2 values in your ratio to the number 1, so you can see what you're getting per pound or per kilogram. Okay? It's used to value for money. So something, they're comparing the cost of 2 things, that's how you would work it out. Using ratios as scales on maps, don't worry about it in Unit 2. Because we do map reading in Unit 3, where you've got to do bearings and scale drawings and so on, you're more likely to get the bigger ratios for maps and stuff in Unit 3. Algebra. In order to work with algebra, you have to be able to read algebra. So this is kind of the texting speak of maths. 2z means 2 times z. AB means A times B. A over 2 means A divided by 2. We've just talked about that. C squared means C times C. You won't believe the number of people that still think that means C times 2. Okay? C squared means C times C. And A over A means A divided by A, which is 1. 10 divided by 10, 1. B divided by B, 1. A billion divided by a billion, 1. One of the biggest things you're going to have to do in all 3 exam papers is substitution. Okay? And that is swapping the value of the letter for a given value that they give you. Okay? So in this case, A squared plus A, if I said to you A is 3, what would that become? A squared, so A is 3. 3 times 3, which is 9, plus the 3 equals 12. If I said to you A is minus 2.
Minus 2 times minus 2.
Minus 2 times minus 2 is what?
4.
Positive 4.
Plus minus 2.
Plus minus 2 becomes
2.
4 minus 2, which is 2. So here we've seen the sign rule for the first time. The sign rule says when you get pluses and minuses between the 2 numbers when you're adding and subtracting, okay, if the signs are the same, you add. If the signs are different, you subtract. And if you're multiplying or dividing, if the signs are the same, you add. If the signs are different, you subtract. Okay? You need to know buzzwords, what a term, an expression, equation and formula are. In algebra, they all are different things. So if a question says, write down the expression for something, you need to write it as an expression and not an equation or a formula. So a term is a number and a letter together, or a number on its own or a letter on its own, okay? We link these terms with addition and subtraction signs, and that's called an expression. An expression does not have an equal sign. An equation is something that looks like an expression, so you have terms that add and subtract, an equal sign, and something on the other side that you can solve. And a formula has 2 or more variables, and you can't solve it because you don't have enough information until people give you the value. When they do give you the value, you can do your substitution and solve it. Okay. Simplifying in algebra means that we can add together like terms. So if you have two lots of x's, you can combine them. So 2x's plus 3x's gives me 5x's. However, you cannot combine terms when they're not the same type of term. So here, 5x can be combined with what? Plus x. And the important thing there, Sam, is the fact that she included the sign that is in front of it. Okay? So we've got plus 2a, and what else have I got? Minus 3a. So I've got plus 2 minus 3, so we're talking about negative numbers on the number line. Minus 1a, but we don't write that, it's minus a. So it gives me 6x minus 2. Are you doing your homework at the back there?
No, I'm just going over a ratio one because I don't understand ratios.
No, you're not. You're just doing the homework that you haven't handed in.
Going over a ratio one, so I don't understand ratios.
Right, multiplying out brackets. To multiply out a bracket, what do we have to do?
Out of the bracket. Multiplying out of the bracket.
You're multiplying out the brackets. What do you have to do?
Times what is out of the bracket, like what's in the bracket. So like you do 2 times.
So the number outside the bracket has to multiply every term inside the bracket. So 2 times x is 2x, and 2 times plus 4 is plus 8. The opposite of that, putting something into brackets, is called factorising in maths. What's the key with factorising? What are we looking for when we're factorising terms?
A common.
Something that's common to both.
Yeah.
So what's common to 5p and 25?
5.
The number 5. So that goes outside the brackets. Ask yourself, what do I multiply by 5 to get 5p? P. What do I multiply by 5 to get 25? Minus 5, not 5. Okay. Linear equations. A linear equation was where x has the value of 1 above it. And in order to solve equations, okay, you need to adopt a rule. And the rule is, do the opposite of what's being done to get the letter on its own, and what you do to one side, you do to the other. And there are 3 types of equations you're going to have to solve. A one-step equation, where there's only one step to solve it. So in order to solve equations, you have to get the letter on its own. So how do I get v on its own? Subtract 2, you do the opposite. What you do to one side, you do to the other. So that gives me v equals 7. When I put 7 in there, 7 plus 2 is 9. 2p plus 5 equals 13. So this is what we call a two-step equation. Again, once you know the process, they're straightforward. Step 1 is take away the 5 first to leave you with 2p equals 8. And then step 2 to solve it, get p on its own, divide both sides by 2, p equals 4. Okay. The hardest equation that they'll give you to solve has a variable on both sides. Okay. So 4a plus 2 equals a plus 11. What's step 1 to solve that? Amber.
Yeah. No, I don't know.
What am I talking about? What did I just ask you?
At the bottom one.
Yeah. So how do I get this started then, Sam?
Would you minus 2 from your 2 and
You can do.
Or am I just going the longest way around?
No, it's quite valid. You can subtract 2 from both sides. It leaves you with 4a equals a plus 9. And then what would you do next?
And then would you... Oh, I found an easy way.
You can still do it. You need all the a's together.
Would you then minus a from that side?
Good.
Minus a from that
Good.
side?
That would leave you with 3a equals 9.
Minus you.
Divide by 3 on both sides.
Could you...
A equals 3.
This is going to sound stupid. Could you do your like term, so then your 4, so it becomes 5a plus...
Well, yeah, you could take the a away first. It doesn't matter which way round you do it. So if you had...
No, I didn't mean that. I mean, could you do like 4a plus an a equals 5a and then your 11 plus your 2 to make
Well, you can't plus an a. Why would you plus an a?
I don't know, I'm just going to do it.
Because it's on the other side of the equal sign. You can subtract an a and subtract an a So all your a's are on the same side. You can't plus the a because the a's all the way over here.
Like the like terms.
Yeah, so you want to bring all the terms together.
Yeah.
Because there's an equal sign, you can't just go for a plus a. That a's got to be brought across. To bring it across, you have to do the opposite. So it's a plus a, you minus a, that leaves you with 3a plus 2 equals 11, and then that looks familiar. Yeah, a two-step equation. Okay, you might be asked to rearrange your formula. That's called changing the subject. So in p equals q plus 12, if I wanted to get q on its own, all I'd have to do was, I want to make q the subject here. To get q on its own, I take 12 away from it. It leaves me with q on its own, but on the other side I've had to take away 12. So I've got p minus 12 on that side and q on this side. This board's all over the place again. Okay. Inequalities. Inequalities, you swap the equal sign for a greater than, a less than, a greater than or equal to, or a less than or equal to sign. Nothing changes. If I gave you something really simple like 2x is greater than 12 and it says solve it, if I had an equal sign there, you just solve it straight away. It's no different with the greater than or less than sign. You just keep the sign there. So how would I solve that? Using algebra. I want x on its own in order to solve it. I've got 2x at the moment. What's that?
Divide 2x by 2.
Divide by 2 to leave x on its own. Do not change the symbol. Divide 12 by 2.
6.
And it's 6. And that's solving an inequality. It's exactly the same as if you were solving an equation that had an equal sign. But instead of an equal sign, we've got this. As soon as this appears, people seem to go silly and not see what the question is anymore. Keep it together when you see those symbols. You might be asked to plot an inequality. Okay? So here, p has got something to do with minus 2 and 2. If you put the circle on minus 2 and 2, p is greater than minus 2. Can it be equal to it? No. So the circle does not get coloured in. P can be equal to it, you colour it in. Okay? Promise me you wouldn't do that. Right, formula. Formulas are changing words into things you can use mathematically. They can give you anything. I can't even predict what they could give you on a formula. So here's just an example. John buys 12 bags of crisps and they cost Z pence. Write what for the total cost of the crisps? An expression. What doesn't an expression have? An equal sign. So they're expecting you to put the information down without an equal sign. 12 bags of crisps cost Z pence. It would be 12 times Z. In maths we don't write that. We write that. That is an expression. They're trying to trick you by saying the total cost. They expect you to do something like that. That is an equation and you would not get the mark for it. Okay. Sorry, it's a formula.
Does that say C at the end?
Yes, it does. C for cost. Because they talk about the total cost here. And some people are lured into putting the equals and the cost in when they're actually asking for this. And that's why knowing those definitions is important. Algebraic arguments. Okay. In order to win the argument, you've got to use the words. You can give an example. You can say, if I put 2 in there, 2 plus 1 is 3, 3 times 3 is 9, so it's always odd. That's an example. That isn't winning the argument. To win the argument, you've got to swap the letter for odd or even. So in this case, W is even, so an even number plus 1 is always what? Odd. Yeah? An odd number times 3 is always, do it in your head, 3 times 3, 5 times 3. Yeah? Odd. That is winning the argument. Okay? So giving an example and putting the number 1 in, 2 in for W doesn't win you the argument, it gives me an example. The argument is won by saying an even number plus 1 gives me an odd number times 3 always gives me an odd number. Okay? Sorry?
I don't understand what the W is.
That's called a variable in maths, and you use a variable when you haven't got a value for a number. Here it tells you W is an even number. So you can put 2 in there, 4, 6, 8 and so on. Okay, we then, a couple of weeks ago, talked about sequences. Sequences have positions, and that's called a term. So the first position in a sequence is the first term, and so on. Okay? Sequences can go up in nice even amounts, 2, 4, 6, 8, 10. Okay? When they go up like that, the difference between the numbers +2, +2, and so on is called the rule. Okay? The rule has got nothing to do with the letter N, which a lot of people in their homework were getting wrong. The rule tells me what I'm doing between each number. You will be asked to complete sequences. How do you complete that first sequence? 1, 4, 9, what's 16, what's the next number?
9. Wait, +9.
So we've added 3, we've added 5, we've added 7, you're going to add 9, and it gives us, we're going to then add what? Okay? That's carrying on a sequence. What are those numbers you're looking at there?
Odd numbers.
Not odd numbers. Square numbers. We did it last week. You should start recognising these numbers like that. 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, 36 is 6 squared. You should start recognising square numbers as well. You could also get a sequence where there are gaps in the middle to fill in. How do you do that? What technique do you use, Sam?
Work out the difference between 9 and 25.
9 and 25 is +16.
And then divide it by 4.
1, 2, 3, 4 steps between the numbers gives me +4 for every gap. So that's how you fill in between them. This +4 is called the term-to-term rule. Okay? That's what they're asked for. So the word rule does not have the letter N in it. Do not start talking about nth terms when they ask you for a rule. We're going on to nth terms now. This is something completely different. This allows us to predict the value for any number in a sequence by working out a rule for the sequence, or not a rule, but a term-to-term rule. So, how do we work out an nth term for a sequence? Step 1, work out the difference between the two numbers. So your term-to-term rule is +3. At this level, that gap will always be the same for an nth term. They can't give you anything harder. It can't be 1, 4, 9 that you've just had. Okay, you can continue more complex sequences, but you can't do an nth term for anything other than something that goes up in nice amounts. So here we've got +3, so what do we do with the +3? Becomes 3n, and then
Find out the difference between 3 and 5.
3 and 5, difference between 3 and 5 is +2. To get from 3 to 5 I need to add 2. So that rule there, that nth term, tells me how to get any number in the sequence. So if I pick the number 4, the fourth term on my sequence, I swap n for 4, so it becomes 4 times 3, which is 12, plus 2, which is 14. And the fourth term, lo and behold, is 14. If I ask for the 100th term, I can swap the letter n for the number 100. 3 times 100 is 300, plus 2 is 302. It saves you writing things out all day long. Okay? Terms can go down as well as up. So here, what am I doing? My term-to-term rule, I'm taking away 3. So to get your nth term, it becomes minus 3n. And now what question do I have to ask myself?
Nothing.
No, how do I get from minus 3 to plus 15? Think of your number line. I have to add 18. So the nth term for that sequence is minus 3n plus 18. Okay, so you still do the adjust at the end, but you have to go from minus 3 all the way up to positive 15. Nth terms allow us to, like we did here, put in any value we like for a position and we can pull out a value. Okay, that's why we use it. It allows us to predict things. It also allows us to work out if a value is or is not part of a sequence. So if I said to you, is 85 part of the sequence 3n plus 2, which was that thing we've just done with 5 and so on, all you need to do is turn it into an equation and solve the equation. Does that equation look familiar? Should do. It's a two-step equation. Step 1, take away 2 from both sides. 3n equals 83. Does 3 go exactly into 83? No. gets a remainder. So 85 is not part of that sequence. If you get a sequence with patterns, turn the pattern into numbers. That's the golden rule for sequences with patterns. So here, if we've got our matchsticks, it's 6 matchsticks, it's 7, 8, 9, 10, 11, and 16. So that's my sequence, 6, 11, and 16. You can then work out the nth term. How do I work out the nth term? That's plus 5, so it's 5n. What do I have to go from there to there? I have to add 1, so it's 5n plus 1. So when it asks me how many matchsticks do I need for the 20th picture in the pattern, I swap the letter n for the number 20. So 5n means 5 times 20, which is 100, plus the 1 gives me 101 sticks that I need for the 20th picture. Okay? And that's why we use it. It could be scaffolding on a big building site. It could be anything, okay? But you need to know how to do nth terms. So we're catching up. Last week we talked about factors. A factor is a number that goes into another number. When you do factors, do factor pairs. If you're doing the factors of 12, 1 goes with 12, 2 goes with 6, 3 goes with 4. Put them both down so you don't miss anything out. Common factors is when you're comparing the factors of two numbers. Write the factors out for both the numbers and see which ones they have in common. This highest common factor, this HCF, is the key. That's the one you're most likely to get a question on, where you write out all the factors for the two numbers and you find the biggest number that they have in common. And that's all it is. So write out those factor lists. Multiples of a number are the products of its multiplication table. So multiples are multiplying. So the multiples of 6 are 12, 18, 24, 30, 36, 42, 48, and so on. The lowest common multiple is when you have two numbers and you write all of their multiples out and you're looking for the lowest number they have in common. So for example, for 3 and 4, you'd write 3, 6, 9, 12, 15, 4, 8, 12, 16, and the first thing that you come to that they have in common is 12. The questions they'll give you won't be as simple as that, but that's how you work out lowest common multiples, sometimes written as LCM. Prime numbers. We should be dab hands at prime numbers now. What's a prime number? It's a number that's only divisible by itself and 1. So what are the prime numbers up to 30 then? You have to know these off the top of your head. 2 is the first prime number. Good. 3, 5, 7, no, 11, 13, 17, 19, 23, 29. Okay? There are 10 that you need to know between 2 and 30. Okay? Prime factors is breaking a big number down into lots of little prime numbers. Okay? So they could ask you to do the prime factors of, I don't know, 22. What two numbers multiplied together give me 22? 2 and 11. 2 is a prime number, 11 is a prime number, so the prime factors for 22 are 2 times 11. Square numbers, it's really important that you understand this, is the result of a number being multiplied by itself. So 25 is a square number, 5 is the number that is being squared. Okay? A cube number is the same. It's the result of multiplying a number by itself 3 times. And you need to be able to identify the cube numbers for 1, 2, 3, 4 and 5. So 1 cubed is 1, 2 cubed is
8,
3 cubed is
27,
4 cubed is on the board, 64, 5 cubed is 125, and 10 cubed is 1,000. So alarm bells ring when you see those numbers. Much the same for square numbers. You should be able to identify the pairs of numbers that give you the square numbers. Okay? So when you see 1 squared is 1, 2 squared is 4, 3 squared, 5 squared, 4 squared,
16,
5 squared,
25,
6 squared, 7 squared,
35.
49,
That's 7 times
8 squared, 64, 9 squared, 81, 10 squared, 11 squared, 121, and 12 squared, 144. And you should have those pairs of numbers in your head so that when you see 121, somebody's ringing a big bell next to your ear saying, it's a square of 11. They're going to ask you something about the square of 11. Okay? So, square roots is the opposite, which is why it's important to know the numbers backwards and forwards. Okay? So, if I said to you, what's the square root of 16? You know it's 4 that is squared to give you 16. If I ask you for the cube root of 125, you know it's relative to 5, and that's why you need to know them as pairs. Okay? Indices. An index tells you how many times to multiply the base number by itself. So in this example, 2 to the 4 represents 2 multiplied by itself 4 times. Okay? Index form is when you tidy up those prime factors into numbers with indices. So last week we did the prime factors for 700, which worked out to be 2 times 2 times 5 times 5 times 7. If they ask it for index form, they expect you to put down 2 squared times 5 squared times 7. That's what they're expecting to see. Okay. We had the index rules last week. You might be a bit rusty on them, but when you have the same base number and you're multiplying, what can you do with the indices? 2 to the 3 times 2 to the 5 is the same as, 2 to the squared times 2 to the 3 is the same as 2 to the 5. You add the indices. When you divide the indices, 2 to the 5 divided by 2 squared, 2 to the 3, you take them away. When you've got 2 squared and you raise it to the power of 3, so that's this brackets 3, you multiply them so it becomes 2 to the 6. 8 to the power 1, so any base number to the power 1 is just the number itself, 8. Anything to the power 0, 2 to the power 0 is? Not 0, it's 1. Anything to a power of 0 is the number 1, and 1 to the power 5, anything to 1 to the power of is 1. 1 times 1 times 1 times 1, a million times is just going to give you 1. Okay? So they are the 6 index rules. You might get a question on those. Finally, we're just getting the last bits now. Okay? Coordinates. You have to be able to plot or read coordinates. X goes across, that's what an X is, so your X coordinates go this way and that way. They're positive if they're to the right, they're negative if they're to the left. The Y coordinates go up and down. They're positive if they're up, they're negative if they are down. So you need to be able to plot them and read them. You might be asked to do midpoints. There are 2 types of ways of working out a midpoint. In Unit 2, my gut feeling is you could work out a midpoint by just drawing or looking at the drawing of the graph they're giving you. So generally they'll give you a graph to plot, and they'll give you a couple of points and say, what's the midpoint? If you draw the line, you can measure the midpoint, or you can say, oh, it's 4 to there, it's 4 up there, so if I go 2 along and 2 up, that's my midpoint. Okay? So you can do a midpoint visually, or you can do a midpoint mathematically. You can say, this point here is 1, 1, and this point here is 5, 5. You add the 2 x coordinates to get 6, divide it by 2 gives you 3. You add the 2 y coordinates together, 6 divided by 2 gives you 3. So your midpoint would be 3, 3. Okay? So you can work out a midpoint in 2 ways. Generally in Unit 2 you can do it visually. Okay? Linear graphs. We've come across the word linear before. It tells us it draws a straight line. It draws a straight line because x has a power of 1, which we don't write down. So 2x plus 2 will always give you a straight line. When you're drawing straight line graphs, you can do it in one of 2 ways. Okay? You can substitute a value of x to work out a value of y. A lot of the times they'll give you a table to fill out, so they'll give you a couple of values already and ask you to work out what the value of y is. It's substitution again, that really important thing in algebra. When x is 1, what's the value of y? If I put 1 in for x, I get 4 out for y. So if I put 1 in there, I get 4 there. So that's my first coordinate. X is 1, y is 4. I go to my graph and I plot it. How many points do you plot on a graph? Straight line, 3. The reason you plot 3 points, is if you've got 1, 2, 3, they should all be in a straight line. If you made a wrong calculation, they'll be all over the place and you'll know that you've done the calculation wrong. Okay? So plotting graphs that way is all about substitution. The other way is using gradients and what we call y-intercepts. If you did the flip lesson offline, you should know that the gradient is the rise divided by the run. You pick any 2 points on your graph, it will always give you exactly the same answer. So you divide the difference between the rise by the run. If you're mathematically minded, we used to call that dy dx. Don't worry about it if you're not, okay? So here I've got a rise of 12 and a run of 4. So 12 divided by 4 tells me it's got a gradient of 3. The steeper the gradient, the more it goes that way. If you have a negative gradient, it goes past the 12 o'clock and it will be that side of the graph, okay? In order to plot graphs using the gradient y-intercept method, you need to understand that this equation here applies to all straight line graphs, where m is the gradient and plus c is what we call the y-intercept. So that when you plot a graph using the gradient y-intercept method, all you need to do is work from your y-intercept. So plus 1 tells me where it cuts the y-axis. It cuts the y-axis there. 3 tells me the gradient. So the gradient of 3 means for every 3 up, I go 1 across. Okay, that's what a gradient of 3 means. So I go 1, 2, 3 up, 1 across. 1, 2, 3 up, 1 across. And I can draw my graph. And that's called the gradient y-intercept method. And they give you things like that when you're doing hiring of equipment, hiring of a bicycle, and so on. Okay, because it tells you how much you pay before you've even taken it away, and then how much you pay each day. The hardest thing to do on graphs in Unit 2 is spot parallel lines. A parallel line is really quite easy in so much as the gradients will be the same, the y-intercepts will be different. So if the gradients are the same, the lines will be parallel, but the y-intercept will be different, which tells you how far apart the two parallel lines will be. Real life graphs, you might be asked to plot real life graphs. We did that with kilometres and miles, you can do it with money and all sorts. Same again, you just need to plot 3 points and draw your line. Once you've got your line there, you can quite literally read off any value. Go up, across, and read off the other value. So here, we've drawn our line for dollars against pounds. So here they've said $36, you go up, it's equivalent to £22. You don't have to mess around with ratios if you have that graph. And one of the different graphs that you might be asked to look at is a distance time graph. A distance time graph tells a story. Okay, I'm starting at 2 o'clock in the afternoon here. So what am I doing between here and here? I'm going away from where I started. I've gone 600 meters. What am I doing between there and there? I'm stationary. I've not gone any distance. I then carry on again, but I'm going flatter. What does flatter mean? Slower. Okay, so that's fast, I've stopped, I start again but I'm going slower, I stop again because it's flat, and then what am I doing when I go down the way? I'm going back to where I started, and once I hit this baseline, my distance from where I started is 0, so I've gone back to where I started. So these distance time graphs tell a story, okay? You need to be able to tell the story. And that's the rapid revision, okay? It's the kind of thing we cover the hour before an exam. We've done it in just over 50 minutes. Are there any questions or any topics you want to go through in more detail that we've just fired through?